With a population of about 35 million, Telangana is the hub of India's southern states. Providing quality and reliable power at an affordable cost are critical towards fulfilling the high growth aspirations of the people in the state of Telangana. With one of the fastest growing sectors among agriculture, industry and services, the power sector is the core engine of the growth in any economy and more so in the newly formed state of Telangana. At the time of bifurcation, the state was suffering from a heavy power crisis, including a 3-day holiday to industry sector and frequent power cuts. There were apprehensions all over that bifurcation would push Telangana into total darkness. But these apprehensions were proved wrong under the able and dynamic leadership of the Honorable Chief Minister, Shri K. Chandrasekhar Rao Garu, who laid the foundation for the huge power expansion in Telangana. Immediately after coming to power, he passed the first GO appointing Shri D. Prabhakar Rao Garu as the Chairman and Managing Director of the Telangana State Power Generation Corporation, an undertaking of the Telangana government. This shows the importance given by the Honorable Chief Minister to the power sector in the state. In accordance with the Telangana government's commitment to provide 24/7 power available to all households, industry, commercial businesses, public needs, any other electricity consuming entity and adequate power to agriculture farm holdings by 2018-19. The corporation plans to meet the demand by a number of capacity additions, enhancing the energy availability from the existing sources. The government of Telangana has been providing 9 hours of daytime supply of power free of cost to agriculture consumers in the state since 1st April 2016.
తెలంగాణ రాష్ట్ర ప్రజల పక్షాన తెలియజేస్తా ఉన్నా, రాత్రింబవలు కష్టపడతా ఉన్నారు, కూడా తీవ్ర చర్యలు తీసుకుంటా ఉన్నారు. రాబోయే ఖరీఫ్ పంట నుంచి పగటి పూటనే 9 గంటల కరెంటు రైతులకు ఇచ్చే విధంగా కూడా చర్యలు చేపడుతుంది ప్రభుత్వం. 10 రోజులు అటుగానో ఇటుగానో మొత్తానికి ఆ కార్యక్రమం కూడా ప్రారంభం కాబోతా ఉందని మనవి చేస్తా ఉన్నా. 24 గంటలు కరెంట్ ఇచ్చే దిశగా 2018లో 3 ఫేజ్ కానీ సింగిల్ ఫేజ్ కానీ తెలంగాణ రాష్ట్రంలో కన్ను రెప్పగొట్టినంత సేపు కూడా కరెంటు పోకుండా చర్యలు తీసుకుంటా ఉన్నాం. 24 hours పవర్ సప్లై కూడా మీకు వస్తుందని చెప్పి ఈ భూపాలపల్లి వేదికగా నేను మనవి చేస్తా ఉన్నాను.
Our CMD has a vision to make the state achieve self-sufficiency in power in the next 3 years with 12,000 megawatt overall capacity addition and to provide reliable and uninterrupted power supply to agriculture, industrial, commercial and domestic sectors and to make the organization the best performing power utility in the country and one of the best utilities in the world with the use of state-of-the-art technology and smart solutions. With a mission to spearhead accelerated power development by planning and implementing new power projects to generate adequate and reliable power most economically, efficiently and eco-friendly and to implement renovation and modernization of all existing units and enhance their performance.
ముఖ్యమంత్రి గారు ఒక 6,000 మెగావాట్స్ ఏదైతే ఉన్నదో యాడ్ చేయాలి అని చెప్పి మా తెలంగాణ జెన్కోకు ఒక మ్యాండేట్ ఇవ్వడం జరిగింది. ముఖ్యమంత్రి గారు ఒక 6,000 మెగావాట్స్ ఏదైతే ఉన్నదో యాడ్ చేయాలి అని చెప్పి మా తెలంగాణ జెన్కోకు ఒక మ్యాండేట్ ఇవ్వడం జరిగింది. ఆ 6,000 మెగావాట్స్ కూడా ప్రైవేట్ వాళ్ళకి ఎవరికి ఇవ్వకూడదు. ఓన్లీ మనం గవర్నమెంట్ ఆఫ్ ఇండియా BHEL తోటే వారితోటే మనం ఈ ప్రాజెక్ట్స్ కన్స్ట్రక్షన్ చేయించాలి అని చెప్పి సీఎం గారి ఆదేశానుసారం ఆ TS జెన్కో ఉన్ను BHEL MOU ఏర్పరచుకోవడం జరిగింది. 6,000 మెగావాట్స్. దాంట్లో ఒక 1,880 మెగావాట్స్ వర్క్ ఆల్రెడీ మొదలైందండి. ఒక 800 మెగావాట్స్ ఏదైతే ఉన్నదో కొత్తగూడెంలో అక్కడ మనది 1,720 మెగావాట్స్ ఉంది ఆల్రెడీ. అక్కడ ఒక 800 మెగావాట్స్ ఆల్రెడీ ప్రారంభమైంది. సీఎం గారు కూడా మళ్ళీ ఒక 1,080 మెగావాట్లకు మణుగూరు లోపల కూడా ఫౌండేషన్ స్టోన్ వేయటం జరిగింది. ఈ రెండు కూడా మనకు వచ్చే 2 సంవత్సరాల లోపల మనకు వచ్చేస్తుంది. ఇది కాక నల్గొండ లోపల దామర్చెర్ల అనే ప్లేస్లో అక్కడ ఒక 4,000 మెగావాట్స్.
తెలంగాణ స్టేట్ పవర్ జనరేషన్ కార్పొరేషన్ లిమిటెడ్ or TS Genco was incorporated on 19th May 2014 and commenced its operations from June 2, 2014 on the same day when the new state of Telangana officially came into existence under the able leadership of the CMD. TS Genco happens to be one of the best performing power utilities in the country in coal-based thermal generation and stands among the top state sector power utilities with the highest plant load factor. Some of its existing hydroelectric plants have been in operation for over 30 years. The company employs about 6,000 staff. In view of its track record in power generation and financial performance, the efficiency of its organizational management can be considered sufficiently high. This organization has a good technical expertise with engineering graduates coming from some of the best colleges both in the state and the country, the IITs and the NITs. The total installed capacity of TS Genco is 5,045.3 megawatts. Thermal power generation is 2,882.5 megawatts, hydel 2,161.8 megawatts, and solar energy is about 1 megawatt. Richly endowed with hydropower resources and coal deposits, Telangana is one of India's few states where balanced development of hydropower and thermal power was possible.
మనం రాబోయే కాలం లోపల ఏదైతున్నదో ఎట్లాంటి నాణ్యమైన విద్యుత్తు నాణ్యమైన ధరకు వారు చెప్పింది ఒకటే, మనం అన్ని వర్గాలకు కూడా నాణ్యమైన విద్యుత్తును నాణ్యమైన ధరలకు ఇవ్వాలి అని చెప్పి దాంట్లో నేను మా టీం అందరం కూడా ఆల్మోస్ట్ రోజులో వారు అంతకుముందు అంటుండేది తెలంగాణ వస్తే మనం 24 గంటలు పనిచేసినా కానీ సరిపోదని చెప్పి వారు ఏదైతే చెప్పినరో అది అక్షరాల నిజమవుతుంది, అది సత్యమవుతుంది. ఈరోజు మేమందరం కూడా అందరూ కూడా టీం అందరం కూడా ఆ విధంగా పనిచేసి మీకు ఇప్పుడు రిజల్ట్స్ కూడా చూపిస్తున్నాం. మేము రాబోయే కాలంలో ఎట్లాంటి ఇబ్బంది కరెంటు తోటి ఎట్లాంటి ఇబ్బంది ఉండదండి.
The Srisaialm reservoir is constructed on the Krishna River in Mahbubnagar district with an effective capacity of 216 TMC. To the left bank of this river lies an underground power station known as Srisaialm Left Bank Hydroelectric Stations (SLBHES). With a total capacity of 150 into 6 megawatts, this powerhouse is being operated by TS Genco. This is the first underground powerhouse in the southern region located 250 meters below ground level. Advantages of this powerhouse are that the units are designed to increase the generation to full output capacity even in 1 minute or even less. The plant load factor of thermal power stations can be improved by providing demand to the power system during night time by taking pumping power. Units can be used as spinning reserves in the system, enabling finer frequency regulation. In addition to the above, these units can be operated as synchronous condensers for supplying reactive power and for meeting the increased peaking demands. The objective of the project was to meet the increasing demand for electric power, particularly during peak hours in the state, by constructing a pumped storage power plant that would utilize the Srisaialm reservoir as its upper reservoir and the Nagarjuna reservoir for pumping the water back to Srisaialm reservoir, effectively utilizing the river flow rate and thereby contributing to the industrial promotion and improvement in the residents' lives by electrification. Construction of this project started in February 1988 and ended in September 2003 over a period of 212 months. This project was India's largest underground power generation plant and the construction was extremely difficult.
With an aggregate capacity of 900 megawatts, the powerhouse consists of 6 units of 150 megawatts each. Also, this is the first hydroelectric project in India with reversible turbine methodology. The powerhouse complex comprises of the following components: upstream intake structure, head race tunnel, pressure shafts, penstock tunnel, powerhouse cavern, transformer cavern, surge pool cavern, tail race tunnel, downstream intake structure with gate controlled shafts, pump turbine and generator room. Intake structure was constructed in the year 1982. It consists of 3 gates to control the intake of water. A rock plug of 16 meters was left at the intake structure and was excavated after completion of all activities in the downstream side. A 15-meter diameter and 347-meter long horseshoe-shaped head race tunnel has purpose of drawing water from the reservoir through the upstream intake structure. The head race tunnel bifurcates into 2 pressure shafts having 12-meter diameter and 190-meter length. This Y junction is the biggest one in India, having compound curves. Each pressure shaft trifurcates in penstocks, resulting in 6 penstocks of 6-meter diameter each. The pressure shafts inclined 1 and 1 create maximum pressure, and the water is driven with a high velocity through penstocks to the powerhouse. The excavation of 236-meter long and 25.6-meter wide powerhouse was one of the major tasks. Top level of the powerhouse is at 165 meters and the extreme bottom level is at 112.6 meters. After the excavation of the pit, draft tube liner is installed. The pit liner on the draft tube increases the water pressure. Water pressure rotates the turbines. The connecting shaft to the rotor drives the rotor, which is installed in stator. This generates electricity and is then carried out to the transformer cavern through bus ducts for stepping up. The transformer cavern, 170 meters in length, 16 meters in width and 27 meters in height, is located between the powerhouse complex and the surge chamber. The generated power is carried from the powerhouse to the step-up transformer and then is carried out for distribution through 400 kV XLPE cables. The permanent access tunnel or PAT carries all these cables to the outdoor switchyard. All the activities in transformer cavern and powerhouse are operated through this permanent access tunnel. The 6 draft tubes, having 10.5 meter width in transit portion and having 1.5 meter thick concrete lining, lead to an intersection with the surge chamber. Draft tubes are equipped with gates at the transition to surge chamber to allow turbine maintenance. The rectangular shaped draft tube section is 10.5 meters in width and 7.4 meters in height. Having a length of 181.8 meters, width of 18.6 meter to 24.6 meter, and having a height of 76 meter, the search chamber is one of the highest underground search chambers in the world excavated without support. After the power generation, water from all the 6 units will be collected in this chamber. From the search chamber, the water is taken to the river through TRT or tailways tunnel. As the length of TRT is too long, the excavation was done from 5 different locations. The downstream intake structure is provided to flow water free of debris and log during the pumping of water back to the reservoir. Because of the Nagarjuna Sagar project downstream to the river Krishna, having the backwaters up to Srisaialm project, it was possible to adopt the reversible type turbine methodology at the Srisaialm left bank hydroelectric scheme. The excavation up to level EL 131 was extremely difficult because of the river flow, which was at EL 170. So, seepage was continuously flooding the lowest working area of the downstream intake structure. Coffer dam was provided temporarily to isolate the downstream intake structure from the river flow. The equipment required for this project, that is, reversible turbines, generators, extra high voltage cables, gas insulated switch gears are all imported. The location of 2 large reservoirs like Srisaialm and Nagarjuna Sagar, one below the other, provide infinite scope for producing electricity at a very low cost. Also, the switchyard is replaced by GIS equipment, which occupies very small space. The power is carried out from the transformer cavern using 400 kV XLPE cables, which are being used for the first time in Andhra Pradesh. The generated power is then led to Vijayawada, Hyderabad and Kurnool. The Srisaialm left bank hydroelectric scheme is the result of 10 years of toil, planning, hard work and combined efforts of hundreds of people. However, unmindful of such heavy risks, this prestigious project of Srisaialm stands proud as the only one of its kind.
This powerhouse has the largest concrete Y junctions in India. 400 kV gas insulated switchgear, XLPE cables are provided for the first time in the state. A total length of around 10 kilometers long tunnels are there in the powerhouse and approximately 25 lakh cubic meters of rock excavation, 6 lakh cubic meters of concreting with 37,000 tons of reinforcement and 2.1 lakh tons of cement are used. Further, this is the highest capacity station with pump turbine installation in India with the provision for condenser mode operation. Diameter of headrace tunnel and tail race tunnel is maximum in India. It runs on a fully automated Japanese technology and is one of the finest engineering marvels in India. Being the largest capacity working hydroelectric station in South India, the powerhouse is undoubtedly the pride of Telangana. The total cost of the project is about 3,000 crore rupees. The 6 Francis turbines for pumped hydroelectricity only began actual operation gradually from 2001, with the final unit completed in September 2003. Till date, this plant has generated about 20,000 million units. The power plant is not only capable of providing direct transmission to the capital Hyderabad, but can also generate power flexibly as the need arises to accommodate frequent fluctuations in power demand. Furthermore, it has the capacity to play an even greater role to achieve the stable supply of electric power. Improvement in electricity services, including reductions in voltage fluctuations and in scheduled outages, was a vital condition for enhancing the investment environment and manufacturing the business efficiency in the state. Therefore, the project can be seen as contributing to the development of the state's industry by increasing the electricity supply capacity during peak hours. By stabilizing the electric power supply, the project has contributed indirectly to the benefits of electrification for the people of Telangana. As part of the project, a residential area or colony for 200 households was constructed on the north side of the Srisaialm reservoir as a community where the power plant employees could live. This community has facilities such as a medical clinic and a school which provides services also to the local community free of charge. Half of the beneficiaries of the clinic and school are local community. The implementation of the project resulted in the short-term employment of about 4,000 people who were for the most part local residents. After completion of the project, approximately 200 persons were hired at the power plants and half of them are local residents.